should be a video. Yes, a draftphysics.com, debatephysics.com video presentation live, which will include the inane participation of other humans, of less than reputable reputation in terms of making useful contribution. But whatever. It's the internet. All part of the fun and such. Internet. Yeah, that's what I said. Anyway, just doing the routine crapola that needs to be done before I can proceed with today's statements regarding just how rotten, stupid, ignorant, and retarded physics and the people who support science are, because it's just such bad science. So, going to explore gravity once again and the factual observation, that, they do know that the Earth has been heated. It is hot, very hot, especially in the center, 4,000, 5,000 degrees centigrade, very hot. And it has all these different density layers that can be understood, that it still has some capacity for the matter to shift its positions, buoyancy, convection. So in this more liquid part, there's lots of stuff going up and down, swirling about, and such. And mostly because there's more heat on the inside than there is on the outside, and it's going to be just a convection argument. So it keeps mixing what buoyancy is trying to make the heavier things sink and the lighter things float, and the other forces are sort of interfering with that simple process. And the question is where did that come from? The argument is, if you do an internet search, it tells you two stupid answers: that billions of years ago meteors hit the Earth and heated it, and it stayed hot all this time. The other dumb answer is that somehow there's an endless supply of new uranium being created, and somehow it's nuclear fuel that's kept the Earth the same temperature, probably, at least for a billion years, a pretty stable temperature. And obviously that doesn't make any sense. You need something to keep shoveling the uranium into the center of the Earth, and there's no shovel, and it just doesn't make any sense. Something with a 10,000 year half-life can't have a consistent capacity to heat something. It just doesn't make any sense. Frankly, it's just almost too silly to even consider. Alright, so the simple truth is by their relativity theory, things just magically have this property of having energy. So no matter where I put them in space, they instantly have energy, based on the fact that I can make them fall towards any body by just giving them a bias in their direction, and cause them to crash into just about anything. It's sort of like somebody saying that I could have the Mississippi River, and I could have boats that were 3 miles inland or 10 miles inland. I could have boats anywhere, and they all have potential energy, because I could put the boat in the river and it would start going. So they just pretend, that this whole idea of energy is just a magical substance in the universe, and that there's all this potential. Somehow we know the river has potential because we can see the mass moving, and yet it has all this other potential, because if I just, instead of building, well, I wouldn't build a wooden car, but you know what I mean, instead of building a shed, I build a boat, then all of a sudden I have more energy in the universe, because I've created something that's more likely to collect the energy from the river, and it's just too ridiculous. But anyway, So it's a simple, from my perspective, the answer to the question is pretty simple. That there's pressure in the external universe already. It's already hot with what we call force, in the form of all kinds of different kinds of photons that we can see. We can detect with our little radios and stuff, and all kinds of energy that we can't see. Okay, so I guess I could draw the can't see part in some other color. I hate to use another color that doesn't erase, but whatever. Yeah, so I mean, there's stuff we can see, and the simple argument is there's bits of this force stuff that we can see and that we can't see, and that's what's in the universe going the speed of light. It's flying around. We can see the stuff flying out of stars, and it hits us. So obviously we know that stuff exists. And the simple truth is when it hits something, it has a little bit of trouble getting through it. Okay, and that's the heat that we see. Yeah, that we know exists. Is the very fact that it's moving other stuff as it goes through the earth, and so it doesn't come out the other side exactly the same vector. Okay, it's a little bit less that comes out than went in, and that's the differential we fall in gravity. Now all of this basically is arguing that the whole universe is just made out of this thing called motion. I would argue that its elemental form is this, the stuff, the little photons, the stuff moving the speed of light. That's the elemental form of motion, and all you really do is you can push tiny things, electrons and protons, you can push atoms, you could push a compound, you can push an element, you could push a Mercedes-Benz. It just depends, okay, on what the force is stuck to pushing. So all you really have is force, free, flying, and force pushing matter. And frankly, it's all could be just understood as heat. It's all just this capacity to move. And so if I'm moving in a straight line in a direction, it means I have heat that's all going the same way. All right, I have a bias of heat in the same direction, and that's it. I have more heat going that way inside of me than heat going that way inside of me, and therefore I go that way because I'm hotter in that direction. And that's all it is. It's always in this form. So when a car is going down the street, you can just measure its energy in terms of stating it's a bunch of heat going in a direction, one direction. So it's a lot easier to see the heat when it's going in one direction and when it's moving something big. And it's harder to see this heat when it's in little tiny little bits, okay, of force, or even little tiny bits of matter. That's a little bit harder to see and harder to collect. So we don't see, okay, what's coming out of the earth very well, and we don't measure it very well, because a lot of it is in a form that frankly we don't have. It's not in a pattern that our instruments can detect, and clearly our instruments are kind of feeble in the sense that they're all frequency dependent. I mean, even this effect is evidence of the frequency dependence, that we're not seeing the conversion of the light that hits me, say whitish, and then it absorbs all the other colors and just reflects this one. And when it absorbs the other colors, it has to re-radiate that energy, that heat somewhere, and we're not seeing any of that because it's in some wavelength that's different than the visible ones. And so again, just another fact that we can only see with our eyes a limited amount, and our instruments are also limited in the sense that they can't see any form of heat. They can only see stuff that vibrates electrons. If it doesn't vibrate an electron, we're not likely to be able to detect it. And I would argue that there's obviously a whole portion of the universe that is vibrating protons, and we don't see any of that, would be the argument. All right, so, I stated in a previous video, I did do a search on Google for some answers, and the answers were just silly. And so there's a Quora page that has some silly answers on it, so I guess I'll read some of those silly answers. And, responses to the accusation that relativity, because it isn't, this system works as an idea, okay, because you can understand what you're just doing is taking little bits of energy that have a direction, okay, so the universe has a bunch of chaos in it. That is, there's stuff moving in all directions. And what matter basically does is when that happens to the Earth, it starts making it work in consolidated directions. So energy comes in all forms, and it all gets sort of bent into one form or one direction, basically going in and out, okay? And that it starts adding coherency to it. So the fact is if I did put something material either falling into the Earth or being pushed out of the Earth, depending on what it could be affected by, whether it was light sensitive, heat sensitive in the sense of infrared, or whether it was sensitive to gravity. The fact is I can take something, this chaotic field, and I put something in it, and it will gain a linear motion, a very straight biased motion in a direction. And that's the kind of energy we like to see, because that's the kind we can use. So the simple truth is we do. Build dams and Niagara Falls, the whole thing, generate a whole bunch of electricity based on this simple idea that the water is going to fall, okay? And it's going to fall basically in a direction with a whole bunch of mass moving the same way. And that's easy for us to put a mechanism in front of to collect the heat. And likewise, it's not that hard to do it chemically, where we take a car engine with a cylinder and we just cause a bunch of chemistry to explode, and then we collect the heat in all directions and we convert it into one direction. So the cylinder feels the heat and the pressure in all directions, but the only part of the cylinder that moves is one direction, and so now we convert pressure in all directions into motion in one direction. So just again emphasizing the point that all motion is heat. Okay, and that's all it is. And so you can have a whole bunch of it in one direction, you can collect it all in one direction, but it's just motion, and there's forms that are easy to collect and forms that are harder to steal from, so to speak. But anyway, so this is a closed system. You can understand that the heat goes in, it gets delayed going through the Earth. Well, less of it comes out now, okay? So if something's sitting on the surface, you could understand that the force pushing from the universe is now, okay, it's very now, right now. And you can understand that the force that would balance it, the pressure on the other side of the universe, that would keep it from falling into the Earth, obviously is trapped inside the Earth, making it orange. Yeah, making it hot, moving pieces of matter. And when matter's moving, the force is going slower than when it's free in space, going the speed of light, obviously. So it gets here too late. And it's just a fact. It's just always a little bit behind. And that's what we fall into, is that differential. Now, if you wait 10 minutes, then lots of extra energy would come out of the Earth. If I turn the gravity off, the whole Earth would just explode. But if I could slow down that release of heat, you'd just see that all the differential in what goes in versus what comes out would be evened up. So if you thought of the heads and tails or something, like heads go in and tails come out, yeah, the heads are a little bit ahead, but if you stop flipping heads, the tails will catch up. You'll get your tails back, and it'll all be even again in the universe. So this is all, thermodynamics is the general subject, and the idea is there should be a conservation in the system, and so clearly the sensible thing to argue is that the conservation is just built out of this time difference. Okay, that the force going in is now, the force coming out is going to be a little late, and that's the simple mechanism. But basically, what goes in eventually comes out, and frankly, it's the same force that causes the what goes in. So it's kind of a perpetual motion machine, and the only thing creating this circularity, this conservation circle, is the fact that you can slow heat down by having it do what we call heat, which is push matter. So when you take force and force it to push matter, you have, in fact, stored energy. Yeah, stored heat. And you'll produce what we call conventional heat. Yeah, I think that's probably not terrible. So yes, their theory doesn't have any circularity. They don't have any accounting for the energy coming out of the Earth. So that's why they keep saying things like, it's old meteor impacts, it's nuclear, blah, 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 some kind of nonsense, because they're really not recognizing the fact that the temperature of the external universe is maintained by the fact that there is a bunch of energy coming off of all of these objects, and sometimes you can see it, like when the sun burns, it's visible photons, but when the Earth burns, okay, they're not visible. We don't see them because they're not high enough frequency radiation, but it's still a ton of radiant energy that's coming out of the Earth and coming out of the moon and coming out of any large material body in space is going to be hot. And it's, again, just a simple pressure argument that every time you take any substance and you compress it, to compress it will produce the symptom of an increase in temperature, okay, demonstrating that it will cause heat, okay. And it's just a fact. And if you want to, if you don't have a steel tank to put something in to maintain a very high pressure, you're going to have to maintain the pressure, and maintaining the pressure means you have to keep adding energy, because you're going to keep leaking the energy out. And that's a simple truth too. So I mean, the fact that physicists would think that the Earth is somehow an insulated vessel, that has somehow vacuum layers or something, and the energy has a hard time getting out, an impossible time getting out. I mean, because realistically we can't make even a very nice thermos bottle, made on the principle of creating a vacuum layer. I guess I could draw it this way, where there's no air. Okay, so you have basically a very strange glass container where there's no air, okay, in that layer. And it still doesn't stop the heat from radiating. It just means that you have to do the radiating through the motion of electrons on the surface. Right? I mean, atoms are really electrons and protons, so realistically heat isn't atoms moving, it's electrons moving, pushing. Okay, when an electron moves, it's going to move into a force, and when it moves into a force, it's going to make its frequency smaller as a reflection. And so that's the simple transfer. So to transfer the energy from this interior glass layer that gets very hot, that layer of glass is vibrating into that vacuum, and it's still going to be pushing on this gravitational force, this force that's always pushing from the external universe, the photon forces. And it's going to be doing this, and the stuff leaving the bottle, the radiation is going to be compressed. It's going to be a higher frequency. So in a sense, it's going to exchange its quick motion for compressions in the field, and that cools the object a little bit. And so the cooling is slow, but it will happen. So we can't make a heat bottle. You know, we can never store heat. We can only store pressure. And obviously the pressure is, in a sense, the cause of heat when you don't have a steel container or some rigid thing to maintain the same pressure. So we can trap pressure, but we can't trap heat. And that's the simple argument. Technical distinction, I would argue, but a distinction nonetheless. Yeah. All right. So I guess I'll go read some of the crap. And I don't know if I you know, it's like, how much do I have to, how much do you need to be fed these simple principles? It's pretty cool that everything but the orange is gone. Yeah, so I can just redraw the earth. I like that. All right. So again, the simple argument is that there's a big arrow that goes in the now energy in the universe, and the arrow that comes out is just a little bit shorter because of what happens in here, and that's the cycle. Okay, that is what we see in the universe. So the energy goes in, gets slowed down. Okay, it eventually comes back out, so it's at equilibrium eventually. All right, and the universe is just full of this external pressure, and that's all that really, that's it. There's just a bunch of arrows going in all directions, these little bits, and that in any circumstance just creates a perpetual pressure on the outside of the universe. The universe itself is full of heat. The little bits moving the speed of light, that's the heat, and you have to conserve that. And the fact is that matter creates a trap. Matter traps the heat. And so if I use the argument of a Sisyphus and a boulder, the matter, the electrons and protons, are boulders, and the fact is when Sisyphuses are stuck pushing boulders, they're not going to go as fast, and so that little bit of delay creates this capacity to have these systems that are storage devices and traps, and the matter ends up sticking together through that mechanism. Now, I would obviously argue that you have to add a few elements to understand charge and magnetism and all this other stuff. There's a subtle difference, between electrons and protons and their interaction between each other. But the basic idea is there are bits of force traveling the speed of light, and we know them as things at a frequency. Okay, red light versus blue light. So there's nothing. This is a photon. A photon isn't a single particle. A photon is an event that hits a surface. It hits more than one place. So when they draw an atom and they say, a photon pops out of the electron makes a photon. Single electron can't do that. It needs to happen to multiple atoms, just like electricity needs to exchange the pressure between multiple atoms. And basically a photon makes electricity. You can understand that. And then you could also understand that the photon's polarization, that is this frequency distance of, say, red light, is 500 nanometers, which would be 1,000 atoms. So photons are big, okay, relative to an electron. And, clearly something that's 1,000 atoms in size can't hit a single electron. That's a little bit unrealistic. Very unrealistic, frankly. All right. So we'll leave it there. And do some of this Quora thing, which I have very little regard for, but only because it came up in the Google search as the source. So AI is using Quora to get its answers, and that's probably not a good thing. So I knew that was going to happen. I'd already changed this, and it just couldn't do the right thing. All right, so this should be it. Yes, it's not in the right form. Okay. All right, so they have all these answers, and they have them ranked, but they're not in order, and it's really irritating. So this is just two, one by a PhD in fluid dynamics, and the other one by a PhD in just about every subject possible in neurology. So he's an MD, he says. But anyway. All right, so the one guy says, I don't think that gravity did generate heat in the Earth's core. So, I mean, it's just so obvious that that's what gravity does. I mean, the fact is you put a piece of mass on the Earth, and every second it applies joules of pressure, weight, that go into the Earth. I mean, it just constantly is denting the Earth. It's just a fact, constantly applying extra pressure, increasing the pressure. And the relationship between pressure and heat is just not deniable, reasonably. I mean, you have to concede that, yes, pressure is likely going to cause heat, especially when you're increasing pressure. That is, you're changing it. I thought it was nuclear reactions. So, again, he's a PhD in all of those things from Caltech, and he thinks the Earth creates uranium, and somehow, even though uranium has a 10,000 year half-life, that is, half the uranium is gone every 10,000 years, that somehow, radioactive decay could be fueling the Earth, keeping it hot for what we know to be billions of years. It's just too silly, right? Yes, too silly. So he did an internet search to the rescue, basically saying what heats the Earth's core, and yes, the conventional answer is meteor impacts hundreds of millions of years ago, and this magical radioactive decay thing. Yeah, two stupid answers. All right. And it's so obvious. I mean, I just don't even know how people could even have an argument about just figuring out that the center of the Earth has a hat, so to speak. Like if you were the center of the Earth and we just said, okay, and you have a head and you have a hat made of zillions of tons of matter that's pushing down on you. I mean, it's an insane amount of pressure. Why wouldn't that be the obvious explanation for the hotness in the center of the Earth? I mean, it's just so obvious. It's amazing that you have to argue this with intelligent people. Okay, so this one says, the heat energy at the center of the Earth during the planet's formation came from conversion of kinetic energy of whatever that is, planetesimal particles. Planetesimal? I never even, whatever. Anyway, and their gravitational potential energy into heat energy. So again, this is the whole argument though. So this magical energy you're giving to objects, giving them motion, giving them momentum, the creation of this free energy essentially, because you don't have a source. Bent geodesic isn't a source. Alright. Subsequently, heat energy has been generated by radioactive element decay. So he just makes the same argument. In all those scenarios, energy is conserved. So just this blanket statement that something called energy is conserved, when we know that all I have to do is transfer the energy, convert the energy from one form to another form, and frankly, both kinetic energy and momentum will not be conserved. It doesn't happen. So just silly answers. So let's go up to the top, I guess. I wish they ranked these things better. They just plainly don't. Okay, so they don't put the top answer at the top. Why does gravity, it says, is the question, heat the center of the earth, not violate the law of conservation of energy? So she says, well, if you view the earth as a solid ball or rock, then it doesn't make sense that gravity would cause the core to heat up. Well, yes, it still would, because it's still a lot of pressure. So again, you can't deny that at each level, okay, the weight gets heavier and heavier. Even though the gravity gets less and less as you go deeper into the earth, the pressure gets higher and higher. All right, if, however, you view Earth as a collection of dust and rock that collapse under gravity to form a ball, that makes more sense. Well, again, we're not talking about the formation of the Earth, and obviously its temperature increase would be very low, like an asteroid isn't melted when it starts collecting matter. And it doesn't get hot until it has a whole bunch of mass creating a whole bunch of pressure. So again, it's, and the real point is, I guess I would argue, is that the energy isn't collected over millions of years. The energy is exactly what we're falling in, the differential between the amount of energy that goes in and the amount of energy that comes out now. Okay, Earth. Any fire, has to be constantly refueled. You can't have a perpetual flame without a perpetual gas. I remember seeing that when I was a little kid, going to Washington, D.C., and there was the eternal flame, where at the Kennedy Memorial or something. I said, I asked the question, like, how could it be an eternal flame? So I was smart enough to know you. And, and my father said, well, there's just, a gas line that constantly pumps gas, And so then I made the point that, well, what happens if something happens to the gas supply and, then your eternal flame goes out? Does God die? What happened? What's the, anyway, the whole thing was just more evidence that the world is full of stupid and idiotic. But anyway, Earth and other rocky planets, so it doesn't matter what the planet's made out of. It doesn't matter what the hydrogen atoms, doesn't matter what you make it out of. Okay, the same phenomena is going to take place. Formed from clouds of smaller particles, dust, rocks, and crystals. Other gases are eventually formed. The solar system condensed over millions of years due to their gravitational attraction to each other. So again, the magical attraction created by no mechanism. The bent geodesical thing. Two tiny particles bump into each other. So then we're saying, okay, that's not really the issue, right? The bumping into each other is just going to be denting each other. So that's not the heat part, right? That's not the end of the energy. So again, I've made this argument, but you could have two cars crush into each other, and they do lots of deformation and bending. Doesn't mean anything. That's not the end of the energy. That's just what the energy's doing to make heat. So the bending doesn't use it up. It still has to be all dissipated as heat, as some sort of thermodynamic event. And so always, heat is just the smallest particles moving. And that's all it really is a definition. It's just small stuff moving. And so obviously you go from having big things moving to have very small things moving. And it doesn't matter what kind of different shapes they've changed shape. It doesn't matter. That didn't use the energy. The energy's still moving in the universe. It's always on the move. It's always been somewhere and it's going somewhere. And it's never, ever, ever ever, okay, destroyed. All right, here's due to gravitational attraction. Two tiny particles bump into each other. Their combined gravity attracted more particles. So again, there's no attraction. There's just the fact that there's an external pressure, and the pressure moves from high pressure to low pressure. Okay, increasing the gravitational pull even more, so whatever that is, the magical mechanism. All right. The larger the ball of accreted material becomes, the greater the pull it exerts on matter nearby. Yeah, so I don't think the person who wrote the question was quite aware of how that works. The point is that seems to be creating free motion, that your gravity attraction thing, okay, is causing things that wouldn't be moving towards it to be moving towards it. And then when it's sitting on the surface, it's applying a constant pressure. And where's the fuel for that constant pressure, that constant motion? What is the gas supply for that constant motion? Okay, all of the tiny particles have kinetic energy. So that's baby talk. I mean, kinetic energy. Yeah, they have momentum is what they have. They have a mass and a velocity. Whether they have a velocity squared is quite doubtable. Okay. As they move through space, and potential energy relative to each other. So this is more baby talk about the boat on the side of the river having potential energy, when no, it doesn't have anything. Okay, until you put it in the river. Okay, as gravity brought these particles together, the magical mechanism, their potential energy relative to one another translated into kinetic energy. So again, baby talk about transferring energy from one thing, potential, to something else called kinetic, when obviously it's either trapped energy, trapped in some kind of mechanism, or it's free. Okay, it's moving in a direction, one direction, or it's moving back and forth, or it's moving in a circle, or it's photons. It's free energy, outside the universe, lighting, going the speed of light. But that's it. There's no other form it can be in. This is such crap. Anyway. So kinetic and the impact, and that kinetic energy is so again he's talking about an impact. The impact energy is real, no doubt about it. Things crash and it causes little bits to fly off, and it causes vibrations and heat to move through the Earth's crust and all kinds of stuff like that. But so does just sitting on the Earth. Constantly I'm pushing into the Earth, increasing the pressure. And it's only through that increase in pressure that the Earth can push me back up again. Alright, the impact of a few particles generates little heat. So whatever that means, the impact of enough particles to build a planet through it, though, is significant. After a few trillion kilos of matter have impacted, the heat energy is immense. So again, he's still talking about impacts. Now we know the impacts are minimal now, and so we know that's not a big source of heating the Earth, is particles hitting the Earth. Okay, so not even a subject. So I shouldn't even bother with how much they calculate it to be, and blah 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 blah. So in reality, the impact velocity of most of the particles is probably significantly higher than that, and all that energy is converted into heat. So again, he's just making this argument that somehow the heat has been created billions of years ago, and it somehow can't get out of the Earth. So somehow the dumb, stupid, moronic, idiotic, unintelligent, uneducated, never went to high school, never went to college, never went to grammar school Earth knows how to create a perfect vacuum, a perfect insulator against heat loss, and we can't. Okay, so we can't make a perfect heat bottle, but somehow the Earth can. You believe that? You're really dumb. Okay. All right. Let's see. Money. some kind of commercial, some sort of related questions. So anyway, so this guy's a surgeon. The planet's gravity only generates significant amount of heat during the formation of the planet. So somehow he just doesn't think all of that weight on the center of the Earth is what has it at 5,000 degrees Celsius. That the pressure created by the constant application of weight doesn't make it hot. Okay, so that's a surgeon. All right, dust and rocks and gas orbit the sun, so that's not terribly interesting. Then by gravity, the dust, gas, rocks collapse, so none of this is happening now. Okay. Falling material has kinetic energy. Where did the kinetic energy come from? The gravitational potential energy. That's where the magical bent geodesic created the free movement. Oh no, you can't do free movement. You have to cause. You can transfer energy. You can't make energy. So where did it get its pushing force from? What is the pushing force? And the simple answer is heat, you fucking dumbass. Yes, that's what the pushing force is. All right. The previously spread out material forms a protoplanet. Oh, so this is just too way off the... It's not even close to answering the question. The material is not moving anymore, says you. Where did the kinetic energy go? When it falls into the protoplanet, i.e. it hits the protoplanet, its speed drops a lot. So it doesn't make much sense, but obviously it transfers its motion into the motion of all the crap it's going to break and fracture and knock all over the place. Where does Ke go? Ke changes into heat, and some Ke is used to move or destroy adjacent material. Yeah, it's not used, though. That's the key word, right? It isn't used to move. It moves, and then it keeps going and keeps doing stuff. The heat keeps going. It doesn't stop going. You can't use the heat. You can only follow it. So all the stuff it's moving, while it's moving, that stuff is using the heat. And when the stuff stops moving, the heat radiates as some other form of motion. It's just in a smaller bit. So if you smash two hunks of clay into each other and the clay spins around and does some deformating, that didn't use the energy. The energy's still there. It's still radiating as heat now. So once it stops moving, it only stopped moving because of friction between the atoms. So all of that is what it's now being converted into. So you're just converting it into heat. You're putting it back into more and more discrete, smaller and smaller little bits of motion. And eventually you put it into bits of motion that are like photons. Very, very discrete and small. All the falling material is at high speed, and the heat is significant. And the heating is significant. So again, he's back to particles hitting things. He's not arguing the simple argument that it's a gigantic amount of pressure, and the pressure is what makes the heat. The protoplanet, after it forms, would be eventually a ball of molten magma. Lord Kelvin computed that it would take 20 million or 400 million years for the Earth to cool from the ball of magma to its current state. So let's understand, Lord Kelvin didn't know what a paramecium was. So, it was really, still archaic science. And he really had no fucking clue. And so it even has a link here. Lord Kelvin's heat loss model as a failed scientific clock. So obviously they have found some defects in the Lord's model of heat transfer. The Earth is not a solid ball of rock which has already lost all of the gravitationally sourced heat. The Earth is not a solid ball of rock which has already lost all the gravitational sourced heat. So again, they keep arguing that somehow the Earth is really good at storing energy. It's an insulated thing. Okay, you put heat in and it'll stay in there, in the bottle Oh, for thousands and millions and trillions of years. No, it won't. Okay, from its formation, because new heat comes from radioactive decay. So again, now he's arguing that, okay, it does leak, but now radioactive decay keeps it fueled and hot. So it's a completely different subject, completely different source of some sort of magical new source of energy. And just absolute crap. So this guy again is using all kinds of different mechanisms that are causing the simple. You don't need to make up a bunch of other mechanisms. You have an obvious one. A ton of pressure is being applied constantly to the Earth from the external universe. It's pushing it really hard, and that's why it's hot. Duh. Okay. The generation of heat at the center of the Earth due to gravitational forces does not violate the law of conservation of energy for several reasons. No, it actually does. The silly theory of a bent geodesic did it is a silly theory. Something real has to do the pushing. It is in fact a push-averse, and if you're going to say something got moved, you have to explain who pushed it, because that has to happen first. All right, gravitational potential energy as matter collapses under its own gravity. So whatever that is, again, its own gravity. Yeah, its own capacity to absorb energy from the thermodynamic temperature of space. Okay, would be the better way to say that probably. Gravitational potential energy decreases. So somehow you're losing energy as you're falling faster and faster. Oh, wait a minute, that doesn't make any sense. All right, the energy is converted into kinetic energy as particles fall inward. Yes, so that part okay, except for the kinetic energy part. They gain momentum. Again, that's the only thing we see is the mv part. Now you can pretend there's a squared velocity part, but you can't see that. So let's just talk about the part we see, which is it's got momentum. Okay, and when they collide, some of the kinetic energy is transformed into thermal energy. So we know that when two things collide, some portion of the energy is converted into heat. Yes, happens all the time. So we know that momentum you can convert into heat. That I can roll a ball on a surface and all of its momentum will be converted into what you could call heat in the ground. And it's only going to be its momentum, frankly. You're not going to make any free heat by calculating its kinetic energy. All right. So that was useless. 2, pressure and temperature. Now this, okay, that sounds like you're getting somewhere rational. The immense pressure of the Earth's core causes, well, obviously it's at the Earth's core, causes the temperature to rise significantly. So it doesn't rise, it just stays really hot. So there's a constant temperature inside the Earth. So, that should be another thing you just recognize. It's a fire, you have to keep putting new wood into it. Or there has to be a gas line. There has to be something that sources the constant generation of the heat. As material is compressed, the kinetic energy of the particles increase. So now he said before that it decreases, but now it increases, leading to higher thermal energy. So again, not saying anything. Yes, high pressure means high thermal energy. Oh, okay. This rise in temperature is a result of energy already present in the system. So again, that doesn't make any sense. How was it present? Where was it the day before? That's the simple question. So before something falls into the Earth and applies a constant mass pressure to the Earth, what was its energy? Where was the energy that's going to do that motion and pushing? Not a creation of new energy. Well, clearly it is the creation of new energy if you don't say the simple truth, which is the universe itself is very hot. It's full of little bits of photonic energy that's going to plow into things. It's applying the pressure. All right, so now, radioactive decay. So just too ridiculous an answer. In addition to gravitational heat. So he's conceding that, I mean, once you concede that any of the heat is gravitational heat, you might as well just stop right there and say all of the heat is created by gravitational heat, because frankly the pressure is immense. So it makes perfectly good sense. And if I had a small rock in space, I would have very little pressure, very little weight on the center, and therefore very little temperature. Okay, the Earth also generates heat through decay of radioactive isotopes like uranium and thorium. So both decay at a rate that is, it's not 1 million years, it's, 10,000-ish. Every 10,000 years, half of that fuel disappears. Every 10,000 years, you got half as much, half as much, half as much, half as much. So you can imagine how much you had to have when the Earth was created till now. Somebody should do that calculation and figure out how many times 10,000 goes into 10 million or 1 billion. Yeah, how many times does 10,000 go into 1 billion? And then figure out how much radioactive material is left. Because it ain't fucking much. Anyway, this process contributes to the overall heat of the Earth's interior. So there's just absolutely zero evidence that this radioactive decay theory has anything to do with reality. They just have zero evidence. No reason to believe it. And it's on its face idiotic, frankly. And is another example of energy transformed rather than creation. So it's obviously the creation, because you got to make more uranium. You can't keep burning the same amount of uranium for 1 billion years and then say, well, I just, made more. All right, so just too silly. All right, thermal equilibrium. So we know the equilibrium's a little bit behind. So the fact is, if I turn the gravity off right now, no more gravity, then everything in the universe explodes. I mean, it's just a fact. Everything's hotter than the external universe, and everything's got under more pressure than the external universe can provide, because I just turned the pressure off on the external universe. So everything is at a positive pressure, and everything's just going to go poof. Yeah. Fact. So there's a ton of stored energy in material objects. Okay. The Earth is not a closed system. So this closed, open system, who's arguing for a closed system? Nobody. The simple question is, if you're going to make something move, you have to explain how did it get moving? What pushed it? The Earth has an orbit. The fact is, something had to give the Earth a velocity to have an orbit. And the fact is, there's some real events. Real things had to push the Earth to give it a velocity. It's exchanged energy with its surroundings, so that's baby talk, whatever that means. The heat generated at the core contributes to the thermal dynamics of the entire planet, so obviously that's the whole point. Where did the heat at the core come from? Oh, it's the pressure. But overall energy is conserved within the system as a whole. So again, just baby talk about some conservation. So you made free pushing force, and that's not free energy, because you're not saying the push was created by pressure in the universe. You're saying the universe creates pressure without any mechanism to create pressure. That somehow it makes pressure without a pump. All right, no heat pump. Okay, dynamic processes. So that doesn't sound like much, right? That sounds like, oh, well, I'll just make up one more paragraph because I just wanted to use the number 5, so I just decided to make up another story. The movement of tectonic plates, so we know this is just surface bullshit, so, that doesn't have much to do with anything, in terms of the real deal heat, the stuff that gets hotter and hotter and hotter as you go deeper and deeper and deeper. Convection currents in the mantle, so we know this is all the byproduct of the heat. Okay, the convection currents didn't create the heat. They're a byproduct of the existence of the heat. And other geological processes redistribute energy throughout the Earth. Yeah, well, obviously it gets redistributed from the center to the outside eventually. So you're taking a small core, whatever. You could say 500 miles across, and you're saying that's really hot. And you're saying, okay, I'm going to expand that out to a big giant mass on the surface. And so obviously that heat is going to be dissipated into a lower and lower temperature. But you have a greater and greater mass that is that temperature. So it's a huge amount of heat. So 50 degrees Kelvin on the outside of the Earth, if you put it into that smaller and smaller surface, gets hotter and hotter, higher and higher temperature. All right. In summary, the heat generated at the Earth's center due to gravitational forces is transformation of energy from one form to another. Force is transformation of energy from one form to another. Right? What was the first form? What was the form that gave the object motion, that had it hit the Earth and then constantly push into the Earth? What's the transformation? What are you transforming? All right. Consistent with the laws of conservation of energy. Some more nonsense about some conservation laws. The only conservation law is essentially Newton's third law. All right. Equal and opposite actions. And that demonstrates that the only thing you can conserve is momentum, because the only thing that a law applies to is momentum. And the simple thing like a cannon or a gun proves that. The recoil of the gun, 2 joules. The bullet, 2,000 joules. Obviously not an equal and opposite kinetic energy reaction. So clearly kinetic energy doesn't obey the third law. And clearly that's a reason to doubt kinetic energy is a real thing. A very good reason to doubt. Alright, so, I'll do one more and then let me see if there's anything in the chat. These people are so stupid. Why are you in Quora? So, this is, is that the subject? No, that's not the subject. I did explain it at the beginning of the video. I said I did a Google search and AI was referencing itself, showing me where it got this information from, and one of the listed sources was Quora. So I clicked on the link, to see what was there. That's why. Fuckhead. Alright, so the other guy says, why is the speed of gravity the same as the speed of light? Because it's the same fucking stuff. It's little bits. How many times have I drawn the little bits? Little arrows with a vector. They're little discrete bits of force. When they're at a frequency, dot, 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 moving in a direction, we call them a photon. So when you have 3 of them, let's say, dot, 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 that would be red light, and dot, dot, dot would be blue light. That's a photon. Now you can understand that I can make different patterns of that force, and it would be different things like magnetism and light and gravity. I think those are the only things. I mean, you could call electricity, but that's the motion of electrons. They're pushing on force between each other, so they have a repulsive force, and so like pushing negative magnets. I could put a row of negative magnets that I could just push on one, and it pushes on all the others. Get it? Yeah. All right. Shouldn't gravity be a little slower? Why should it be slow? I don't even understand that. I can't even imagine why I would think the discrete stuff, the little force bit stuff, why would I think any of it should have any different speeds? Why? Why would I think that? I mean, photons demonstrate that it's always the same speed. Doesn't matter. I can't change the fucking speed of this shit. So I already know it's whatever the Sisyphuses are, whatever the elemental motion in the universe. The elemental motion in the universe clearly doesn't have any speed control beyond picking up heavy things Sisyphus boulders and having to carry them or push them. And they can't go as fast when they're pushing a boulder. Their wheels are still spinning the same speed, but just, they can't create free mv. So as soon as the mass increases, the speed has to decrease. And that's the simple answer. So he says, no, you don't understand. The force bits can push at their same speed. What do you mean they can? So it doesn't matter how heavy something is, they can push it all the same speed. Well, that sounds like something Leibniz would say. Leibniz actually believed that. He actually admitted that he believed something that's silly. That you could take the same P and you could hit a P with the P, or you could hit a giant boulder with the P, and the giant boulder would leave at the same velocity that the little P would leave at. You actually believe that kind of silly shit. I'm sorry you're stupid, but look, the whole argument is that the force is the only thing that has motion. The matter is dead. Electrons and protons have nothing. They have no jet engines. They have no fart mechanism where they can shoot gas. They don't have any way to move. And the only way they can move is because force pushes them. It forces them to move. And the only way the force can do that is it has to stick to it. So matter carries force. It has to use the force while the matter is moving. It's using the force. The force is now being used to push the matter. And then when the matter releases the force, it goes back into being a photon, flying free at the speed of light. You can't understand an argument that simple? So you have a Sisyphus. When they're not pushing boulders, they go the speed of light. When they're pushing a boulder, they're going less than the speed of light. And then when they stop pushing the boulder and are free, they go back to being the speed of light. That's too complicated? Fuck you, people are stupid. This is amazing. Frightening. It's not just amazing, it's frightening. That, like I said, these silly arguments are being made by people, with an education. All right, so this guy doesn't tell us who he is, surgeon or whatever. I think there's two questions here. Gravity plus relative movement generates tides. The frictional losses convert to kinetic energy to heat. So again, this magical tidal something or other that somehow does something or other. So that's not anybody's explanation. So nobody says that tidal forces are heating the earth. I suppose you could argue that the very fact that there is this connected tension creates the possibility that if you jiggle one, the other one's going to have to be jiggled. But sharing a state and being able to create extra heat are two different things. All the moon and the earth could do was transfer heat between each other. They can't really make new heat. Static gravity does not generate heat, so we know it does. We know it can't be avoided. I mean, I could make a contraption to sit on, right? Like some sort of plastic. And the simple truth is just by sitting on it, applying my weight, it would get a certain temperature. And it would stay that temperature. It would be constantly running a temperature merely because I was sitting on it. Not transferring my body heat, but I just mean just transferring the pressure. So the pressure always creates heat. But the pressure it generates does not affect temperature distribution. So we're not talking about the distribution of temperature, we're talking about the creation of it. And again, it does in fact create the heat. All right, the situation is relatively straightforward in gases. Yeah, and so where in gases are you going to be able to make this excuse that higher pressure doesn't mean higher temperature? Because that's exactly what happens. Okay. The lapse rate is identical to the temperature change of the particle of gas changing pressure as it rises or falls very slowly through the mechanism is generally viewed as somewhat differently. So again, it's not really about, I mean, obviously the fact that you don't instantly lose temperature is only a fact of the fact of what you're conveying it to. So it depends on how hot you are and how cold the other surface is. So if the other surface is really cold, you'll lose your temperature really fast. So again, that's just some more bullshit. It depends on what the pressure differential is, will decide how fast the pressure will be released. So I could have 10 pounds relative to an absolute vacuum, or I could have 10 pounds or 100 pounds relative to 90 pounds. Well, which one is going to be transferred the quickest? Well, yes, the 10 pounds, because the relative difference is so much higher. So, you know, these people are just so full of shit. Minus as change of kinetic energy of the individual molecule modified by interaction with molecules. Obviously, you can only transfer the energy, so you know, you just follow the motion. You can't make new motion, you can only watch the motion move from one object to another. The temperature of the gas rises with reducing altitude. So again, this doesn't have anything to do with anything. Right? I don't know what the reducing altitude thing means. So as you reduce the altitude, the temperature increases, you know, from our perspective. So if you're saying reducing altitude means going into the earth, yes, eventually you'll have less gravitational pressure, but you have more chemical pressure. The physical parameter here is the sum of gravitational potential energy of pressure, and thermal energy. So again, it's all the same energy. You can't change it. The pressure is converted into heat. The pressure is motion. That motion is converted into motion of little things. That's the fact. Big things move, then little things move. A trio generally abbreviated as potential temperature. So there's no such concept. I've never even heard that anywhere. So that's just, he just made that shit up. Now this later description of warming with increased depth must apply equally to liquids and solids. So no, it doesn't apply equally. So the fact is, if you put something in a solid form, the fact is it may not be capable of getting hotter and hotter because it just transfers the heat. It just goes right through it because you can't make the atoms any closer. You can't increase the density. And if you can't increase the density, if you can't change the density, you can't use the pressure. The pressure can't be converted into anything. So that's where it gets a little interesting, is that the hottest part of the Earth is the center, and it's pretty much been demonstrated by earthquake vibrations and different things that the energy travels through the center quickly because of the very fact that it's solid and it can't expand, so it can't change its temperature. So there is no doubt under equilibrium conditions temperature will increase with depths below the surface. Yeah, that's the whole point, moron. Now the question is, what's causing that increase in temperature? Magical things or something real, like a real pushing force of gravity? I see no reason to expect that the concept of potential temperature, so again, there is no such concept, should be any different for liquids and solids as it is for gases. Well, you're pretty stupid then, because liquids are uncompressible and solids are really uncompressible. Alright, so another moron. Let's see. Yeah, he doesn't even have upvotes. I don't know why. Yeah, I don't know why these are. I don't know why. Yeah. The apex force, okay, so we won't bother. That's already kind of weird. That reacts with mass and generates gravity is carried by waves of extremely long wavelength. Well, yeah. I don't think he's really on the subject. It's cheaper to buy a car insurance, so I don't really care about that. So I read these two already. That's a commercial. All right. Actually, gravity still generates heat. Okay, because the Earth is not solid. So, well, whatever. I mean, solid is a tricky word, isn't it? Yes. Heavier materials continue sinking down to the center, losing their potential energy in gravitational field. So I don't even know what that even means. Losing their potential energy in gravitational field. So the molten stuff that's moving only because of convection, because the center is hotter than the outside, that's the reason why it's moving. Okay. This movement generates heat. No, it's already hot. That's why it's moving. It's because it's already fucking hot. Okay, some scientists even hold the view that this is a major source of internal heat. Gravity is a source. Yes, that's the source, the only source, frankly. But dominating view is that it constitutes only a minor part, while a major part is done by radioactive decay. So there it is again. So I'm supposed to believe that these smart people never thought about the fact that radioactive decay as a concept is dependent on half-life. That we can't even run a nuclear power plant for a few years without expending the radioactivity of the material. We kill it. We degrade it. We turn the substance into some other substance that isn't as stable and as useful. And that's the fact. And so we have to dump the crap and put new fuel in because we expire its usefulness. The heat generation mechanism, there's no way violates the law of conservation. Well, obviously it does, but okay, keep telling me it doesn't for magical reasons. The internal energy for this is a potential energy of gravitational field created by parts of the plant when they were still separate pieces. So he's basically saying that the crashing forces are the only generating forces. So you have to hit the Earth. You don't have to just sit on the Earth. Sitting on the Earth doesn't make it hotter. Crashing into the Earth makes it hotter. Ridiculous nonsense. Okay, the energy is going down while the heat energy is going up. So that's impossible, frankly. And again, as I've sort of argued, energy is just heat. And when the heat's going all in one direction, we call it useful. And when it's scattered and going in different directions and in discrete little bits that are hard to collect, we call it heat or waste. Okay, while heat energy is going up, more exactly it isn't. It is radiated away, becoming energy of IR photons. So again, and what are IR photons doing when they hit something else? I think they're pushing on it. Yeah, so when they hit something else, I think they push on it. Oh, God, people are so stupid. All right, MA in economics. Well, this guy shouldn't know anything at all. You can't even capitalize the paragraph. The very short answer, it doesn't create energy. It merely concentrates it. So that's like storage. So that's true. Okay, that's all you're doing. You're just storing some percentage of the energy that goes in is held up. Okay, stored. In a way, if the Earth were floating alone in space, it would cool down and eventually freeze completely, including the core. Well, how would be floating alone in space? So what you needed to say was, if you turned gravity off, you turn the exterior pressure off, then the interior pressure can be released. But it can't be released as long as the exterior pressure keeps applying pressure. It can't be released in terms of all of it. It can only reach an equilibrium with the external pressure. Okay, so again, just so poorly stated. It is the pressure that raises the temperature inside the Earth. So right there you're saying it. Gravity created the pressure, therefore gravity created the heat. So instead of just answering the question, yes, you're quite correct. It is free energy. Bent geodesic is free energy because you created pressure without explaining where the pressure came from, what causes it. But the actual amount of energy is not increased. So that's the part that doesn't make any sense. Of course, it has to keep coming out. It has to keep going in. If it keeps coming out, it has to keep going in. If it keeps coming out, it has to keep going in. Okay, except for the same nuclear fusion that might happen. So again, that's just nonsense. I mean, fission. There's no evidence that anything's fizzing, okay, inside the Earth. Not sure about that. Well, that's just useless. Okay, I'm not sure that's a very good answer. Is what oh yeah, so I guess I read a Wikipedia page, and yeah, it's not a great answer. You know, too ridiculous. Its core we never saw. Gravity opposed heat. So that was a really brilliant. I don't know why they don't just delete that one. Because it's the conservation of potential energy into heat, totally conserved. Yeah, another guy that just deserves to be smited mightily. So anyway, let's see if there's any other comments. And maybe I'll just say, well, we've probably seen enough of the bullshit answers. So fucking stupid. Oh, this guy is a Harvard graduate. Oh, yes, and it's one sentence. Yeah. Why is the Earth pulling everything but doesn't lose its gravitational energy? Gravity does not work like rope pulling competition. Yeah, because it's a pushing force. Oh, brother. Let's see if he has anything else to say. After a while of pulling rope as hard as you can, your muscles get tired. Oh, this is like the spar kind of horseshit. You become exhausted, and if you don't actually move, you lose a lot of energy. So obviously, you lose it to places, though. The ground, you're pushing on. The rope, you're pushing on. There's things that are going to get hot and radiate the waste. Here's another example. Holding a heavy TV set is hard. Most of us can do it for a few seconds. So this guy is really old. Because I don't think most people now have ever picked up a TV. But the same TV set with the same weight can be placed on a table or stool and be constantly held up for years without any expenditure of energy at all. So they're saying that the table feels no pressure and doesn't in any way produce any heat, which again just denies the facts that the whole subject is that yes, it does. You know, it's a very small amount, but it's obviously anything under pressure will get hot if you're applying the pressure, changing the pressure, constantly applying the pressure. If the pressure has to move through the object will get hot. So what is actually going on here? Muscles are extremely wasteful. So again, it's just wasting time on this muscle crap. Okay, energy or work are only required when an object you're pulling, so the more nonsense that there's such a thing as a pull, moves in the direction of the pull. So obviously things move in the direction of the push, go from high pressure to low pressure. They don't go from low pressure to high pressure. Okay, if it moves in the direction of the force, you are transferring energy to the object. So again, you're not transferring per se, you know, in any other sense than saying, I have it and I can give it to you like a currency. And so you really have to collect energy before you can give it. You can't give what you didn't collect. And if it moves opposite to the direction of the force, i.e. pushing, pulling you, then the object is imparting energy on you. So we never know relativity, you know, in our incomplete view of things. We don't know exactly who's got the actual extra energy in many impact circumstances. So two things hit each other, we can't be sure who hit who. But the fact is, somebody hit somebody. Yeah, one of them does have more of it, and one of them has less of it. So Earth's gravitational field pulls all massive objects towards it. So whatever that means, that's a non-answer to the question. We're wondering what is doing this pulling or pushing. If the object is at rest on the surface, no work is done. So that's the silly part, because we know the whole point is the Earth is burning, melting, because of the tremendous amount of work being done on the Earth. Ton of work is pushing through the Earth. If an object is in orbit and it's and has motion but is not in the direction of the pole, it's perpendicular, so no work is done in that case either. So he says so, but there's no evidence that it isn't absorbing, because that's why it itself has gravity. So all material objects are expressing a gravitational field, okay, and they only can do that because they're absorbing some portion of the field. All right, but if we went to shoot a rocket into space, we must extend a huge amount of energy to counter Earth's gravity. That's the whole question at hand, isn't it? Is it the same energy no matter what speed I travel? So it's 9.8 meters per second, per 1 second, of change in your motion. So clearly, if I go really slow, I'll do lots of work, and if I go really fast, I'll do very little work. All right, and when it comes down to it, gives back all the energy in the form of heat. So obviously, you can't. Energy will always be conserved, yes, and it's always heat in the first place and heat in the last place. However, Earth does not have some infinite amount of energy. Well, obviously the Earth doesn't have energy in the sense that it doesn't have any of its own. It has to acquire it from something. Okay. After which it will run out of energy and stop having gravity. Well, obviously, yes, the force is coming from the outside in, not the inside out. Okay, Earth's gravitational field can be seen as already having negative energy. That's your perversion of reality. The concept of negative energy must be employed for some reason. Now, why would you invent negative energy? And it's allowed to go into as much energy depth as it wants. It has infinite credit in its energy account. So whatever that could possibly mean. It's not free energy, it's infinite credit. That sounds like complete bullshit, right? Yes. So people are losing fat by injecting themselves with some sort of shit. Okay, well, whatever. Commercials. Very interesting. Alright, enough of this. Tedious and annoying. Alright, let's see if there's any comments and we'll get out of here. Alright, so Sisyphus can push as fast as he can run. So this is, I'm just sorry. I just made it as clear as I could possibly make it that the Sisyphus can't push the boulder the same speed the Sisyphus can go when he's got no boulder in front of him. If he's got to push a boulder, he and the boulder will move slower based on how much mass the boulder has or how many Sisyphuses are pushing it. So if 2 Sisyphuses are pushing, they'll be able to go twice as fast. And if 3 Sisyphuses are pushing, they'll go 3 times as fast. But it's always slower than their native speed of when they're not pushing a boulder. You're just not even trying, right? You're just trying not to understand, right? You're just doing everything you can to not understand because you want to play with your poo and eat it. And so you're just making excuses to not understand why you can't understand your life will be better if you don't play with your poo and eat it theory. Oh, God. It's better than Reddit. Well, whatever. I hate both. I hate all of the internet. So I hate all these. I mean, the amount of commercials is obscene, frankly. And, every other post is a commercial for some sort of crap. And it's always crap. That shouldn't be the internet we would expect. We should have an internet created by non-profit foundations or something. We shouldn't have to be bludgeoned by all of these for-profit lowest common denominator, how much can I graft? Because the graft can only come from doing something stupid people like. You can only make money advertising to morons. So you have to sell something morons want. So everything becomes moronic because only the morons are paying the bill. Smart people don't pay the bill for crap on the internet, right? So, you're stuck with something designed to make dumb people happy, not something designed to inspire intelligent people. I'm just arguing, whatever. I really don't want to make a comparison, but frankly, it's all crap to me. I spend no time at either. Okay, so I don't waste my time asking dumb questions to dumb people. But Wikipedia is just as bad, you could argue. The authorities, there's nobody, there's no mechanism built in, like I said, that's accountable in any kind of real sense. Like I said, if they're democracies, then they're going to fail because democracies allow dumb people to pollute smart people, to pollute the judgment of smart people. So you can't have some open democracy. You really do have to have some sort of system, okay, that merit pay, some sort of credibility based on actual, not pleasing morons, but doing something better than pleasing morons. And so it's a real problem. I mean, the fact is that even if you have a jury of intellectuals, college graduates, as proven just by these core things that I just read, that college graduates doesn't mean much. So there's no standard for people who are smart enough to make reasonable judgments. I mean, it really is. You're just stuck with benevolent dictator or you're fucked. I guess I don't think it has to be exactly that bad. I mean, it seems to me that there should be some capacity to find the difference between reasonable people, careful, thoughtful people, versus reckless, shit-talking people. And unfortunately, there's just not enough emphasis on filtering human beings for their the integrity of their reasoning skills. Let's call it that. Yeah, well, so the guy says Reddit, Quora, Wikipedia, they're all good ideas but bad in practice. Well, isn't that the same thing as a bad idea when it's bad in practice? So, but the key, I had this argument 25 years ago, okay? When the internet was being formed, I knew the guy, we used to call him Jumbo for some reason. Anyway, the guy who invented Wikipedia, I think that was his name, Jimbo maybe? Yeah, whatever it was. Anyway, and so I did have conversations with him, in text exchanges, because we were arguing about indexing the internet, and how do you rank websites without bias? So, and how do you create a community of people who would do this job of filtering websites and saying which ones have integrity and which ones are crap, and who does the filtering. And the fact is, because a bunch of people who are self-interested will end up being the editors, because they'll just put their own websites at the top of the list and that kind of crap. So it was this whole idea of how do you do that, and so he was kind of selling Wikipedia as a form of a search engine, that it would be a reference that would take you to, better information on a subject. So not only would it provide a Wikipedia, an encyclopedia, but it would be also a reference guide. Now, obviously, Wikipedia lost all interest in doing that, right? They hate links. They will not link to any other sources. So, I mean, they completely fail as an indexer of where to go to read more or to see sources. Their sourcing sucks. I mean, they have a whole list of footnotes, but the sources suck. All right. They're all behind private, they're all books you have to go buy at the library or, buy at a bookstore or something. Anyway. So the really argument it came down to was, how do you do this thing of selecting who gets to, run the show and edit, and how do you edit the editors? I guess that was the, how do you manage the editing community and make sure it's not corrupt? And in theory, it's possible. Okay, but it requires the editors to have a democracy of integrity. Like most of them have to have integrity. So it's like our own democracy, right? All the politicians are grafting cheaters, so they defend grafting cheating. They give themselves immunity from prosecution. Why? If the majority of the politicians had any integrity, they wouldn't give themselves immunity. Why would they give themselves immunity to be criminals? They'd say, no, you should be able to sue me if I violate your constitutional rights on purpose. Yeah, that should happen. So so that's what happens is as soon as your editing community gets corrupted by enough crooks, then the crooks run the show. And that's it. You're over. You're done. It's a mob. It's not anything useful. It's just mobsters. Anyway, way off the subject, I think. But yeah, I did spend a lot of time thinking on that subject, and I'd like to try some things, where, like even on YouTube, there could be all kinds of ranking, and you get good citizen points and bad citizen points, based on how many people block you or how many people this or how much, and that there could be some way of seeing, who's a troll and who's not a troll and all that kind of stuff. It really should be all open and everybody could see what everybody else is up to. That's how it should be. I should be able to see where you assholes comment and what else you do on the internet. That should be part of me understanding what your commentary means in context. Who are you? What are you? And all of that they took away. You used to be able to do that on YouTube. You could just type in somebody's screen name and you could see the comments they made. Yeah, well, sourcing is important and all that kind of stuff. I can understand but I'm just saying that they should be at least open to allowing there to be a section that people can voluntarily read if they want to see more. So they should just say, well, look, this is what we're going to say. Now, there is some dissension, and so if you click this button, you can see what the dissenters say. And that's the part they just don't make accessible enough, is the dissension. But obviously, sourcing is really important. Frankly, sourcing should be pretty good in the sense that your sources are things that really did the experiment somewhere. They're not just shit talking. Or they can draw a drawing of it. That's really important. They can make a model of it. They can do something to make it credible. And, there's just way too little of that in either the authorities' answer or the crank answer. Many of the cranks, that's like the flat earth or something. They got nothing. They should ban IP. Well, obviously IP addresses don't mean anything anymore. Formatting and require them to register. It's basically a rule over there that Wikipedia that once you reach a minimum amount of edits, you're sort of forced to create an account. So I just find it useless for it to even be an option. Well, yeah, I would argue that I don't see much point in it anyway. Anonymous bullshit? Fuck anonymous. I mean, if you're going to edit the encyclopedia, everybody should know who the fuck you are. I mean, there really should be strict accountability. You know, if you're found to be wrong and you're wrong for some corrupt reason, yeah, then you should be banned. I was banned for life, you know, merely by pointing out that, you know, the stuff you have on, you know, their Wikipedia page had merely pointed out how, frankly, it doesn't make any sense and it's unevidenced. So until you have a source for what you're saying, shouldn't that be stated as a, you know, who knows? It might be a possibility. It could be a possible answer. It shouldn't be stated as a fact when you can't really source it. So if you're going to tell me there's quarks, you should show me the evidence that there's quarks, not tell me that Richard Feynman thinks so. Richard Feynman thinks so isn't good enough. Yeah, lots of great people in New Jersey. I mean, the real point is, you know, the edit should be debated among the editors. But what shouldn't be a problem is the debate. You should be able to have the argument about the stuff without being banned for merely having the argument, by merely saying, I don't think you have, you know, provided good evidence for the assertions made on the page as being facts that aren't facts because you really haven't they haven't been demonstrated with evidence. So my claim, I'm not asking you to publish my claim. I didn't edit anything, right? I just merely made the statement that you're stating something as a truth and that it's been proven by science. And the argument is it hasn't been proven by any science. It's merely been stated by science. So, and they wouldn't even allow me to do that. So I couldn't even state that they were wrong to publish stuff as truth when it hasn't been demonstrated to be the truth. And they won't even accept that criticism. I didn't try to edit anything. They banned me for life. That's the simple truth. I didn't edit any page, and they banned me for life. Oh, I don't even want to look at the pages on eugenics and race realism, so I don't even know what you're going, why you're even going to a page like that. Frankly, because you know that's just a very messy subject. But obviously I don't think there's anything racial, okay? It's a tiny amount of our chromosomes that are different, and it's not a significant difference. It's just bullshit that people would make something out of that crap. It's all cultural, it's all environmental, and that should be the argument, is whether, you know, if you're going to do a eugenics argument, my only argument eugenics-y wise is that obviously people should breed cancer out of existence. I mean, that's what we could do for the human race, is we could just understand that, well, if we're going to do this make people thing, let's make people that can't get cancer. Yeah, it'd be really clever, wouldn't it? Yeah, I know, but they do the opposite. They let the wretched refuse breed with abandon, with no abandon. But anyway, that's not the subject of this video either. Alright, people, if you really can't get on the subject, get back on the subject, somewhere around the subject, then I'll just toddle off and try again another day, and whatever. I mean, it's just so discouraging. Like I said, there's just no point in having the conversation with people who frankly are just too ignorant because they don't know enough of the physics. And so, you know, you got to get somebody who knows something about the evidence and the fact that there isn't any. Yeah. You know, in the argument. I mean, they have to be able to explain why they never repeated the Eddington experiment from space, and, you know, why in all these 350 years of talking about v squared, you don't have any evidence of v squared. Alright, running out of time. Maybe I'll pop the chat up just for... See how dumb it is? People are dumb. Let's see. Yeah, it's not here. That's interesting. Let's try this. And then I'll try this. And then I'll try this. And there it is. Alright. So I should be able to move that over here and humiliate the chatters. Yeah, just humiliate all of you chatters. Look how stupid they are. Yeah, they can't say anything worth anybody paying any attention to. Let's see. So this is like a fake account, no doubt. So we'll just get rid of wiki predator thingy, whatever he is. Fuck you. You're obviously a waste of time. 24 hours is fine. Thank you. The subject really isn't Wikipedia. I mean, you know, it's just a demonstrable fact that they will not accept any criticism. The editors are authoritarian gods, and they think they're all too smart, and they're not. And if you point it out and you prove them wrong, they'll get very upset. I mean, that should be like one of the standards. You know, it's not so much about how many articles you've edited. It's about, have you made any mistakes? And they really should just, you know, based on the number of, you know, they should really have an aggressive ability to look for They're all, almost should be Wikipedia editors. They're just devoted to debunking the editors. Just like the Justice Department should run completely independent of the political crap, and their whole object should be to entrap and and make a mess out of the, to demonstrate just how corrupt the judges are and different people. That should be their ambition, is to catch them, in their lies and crookedness. But unfortunately, that's not their motivation. They don't wish to clean house. Professor Dave called you a moron, so what? I called him a motherfucking, ugly motherfucking cunt, slimy, dirty anal turd, cancerous pile of retarded nonsense crap shit. So what? Fuckhead. Yeah, did you hear about him calling you a moron? Well, I don't know what you're talking about, so I guess I don't know what you're talking about. I talked to Professor Dave 2 years ago, what it was, 3 years ago, and he displayed his own, what he's about. I mean, he said, I asked him a simple question: how much does it cost to have you discuss these subjects? And he said $5,000. And I made the simple argument, well, I don't think you're really worth $5,000, frankly. I'm not going to pay you $5,000. You got to come up with a more reasonable number. If he would have said 1,000, okay, game on. But he couldn't even come up with a reasonable, how much I'm going to pay him to answer a physics question. I have to pay him to defend his physics? How ridiculous is that? So don't really get your points. Don't even get your point. Involuntary suffering. What does that stupid icon mean? Ugh, fuck. I mean the emoticon. Oh, I mean, just amazing. What are you talking about, whale man? Professor Dave is scared shitless by me. He won't have any conversation with me because he has no answer to these simple arguments. You think he can defend kinetic energy? Do you really think so? There's not one single video on his fucking website that explains how levers work or how pulleys work. Okay, explaining them in terms of kinetic energy. Because they don't work in terms of kinetic energy. So you won't find any video where he'll use the word kinetic energy and describe how pulleys work, because kinetic energy has nothing to do with it. He won't do it about levers and kinetic energy, because levers don't have anything to do with kinetic energy. There's no such thing in their universe. Again, Newton's third law. Let him talk about Newton's third law in terms of kinetic energy, because you can't do that and be rational. I think it'd be great if Professor Dave would, we could do a podcast. It'd be about asshole versus asshole, frankly, and that'd be great. I mean, in the sense that spy versus spy. I mean, there's going to be somebody wearing a white hat and somebody wearing a black hat, because we won't agree on a motherfucking thing. Oh, Jesus. So you're just saying block me, right? If Newton were alive today, would you smoke weed with him? I mean, just what the fuck? Just get what you deserve, you fucking piece of human garbage. Where is my choices? I want to block this fucker. Ugh, what an asshole. Yeah, Newton wasn't exactly, Newton, you couldn't even argue that Newton would drink a glass of wine. He was so devoted to his causes. Okay, I mean, he didn't really waste any time barely petting his cat. Okay, I mean, there's just no point in turning Newton into a pothead. I mean, Newton is described as being a rather surly, not very friendly kind of sort. And I think he had a real contempt for other people because he probably saw them all as just wastes of neurons, as I do. I mean, they're not even trying to get their life right. I don't think he was asexual. He might have been homosexual. He might have been a pedophile. Who the hell knows? I mean, obviously, he didn't, have much desire to enjoy traditional sexual relations with women. But I don't think he was unsexual. I think he knew what those desires and drives were. He was he was a god botherer. There's no denying it. And so maybe he just took it kind of seriously that yes, my sexuality is just a way of destroying my productivity. I mean, I frankly have lost all passion for relationship, yeah, with anything in a sexual way, because yeah, it just gets too tangled and gnarly and caught up in a whole bunch of emotional horse shit, and it's just like, what the fuck that. So it's all just a head game. So frankly, I'm quite satisfied to have you know to confine my relationships to ones with fantasy characters than reality characters, merely because it's just so much simpler. But anyway, that's just not part of this subject. I mean, it's just a simple fact that I did just fine as an adolescent finding something to have sex with, frankly, when nobody would have sex with me. So it wasn't a problem. So, and then you just figure out, hey, I could just go do that. That's fine. What do I care? I mean, do I really need all of the other crap that goes with it? Do I need to be, pussy whipped, and living, conforming to role play and doing all of that crap when, no, I'll just be me. And, like I said, I did okay before I ever got laid, and, it worked. I didn't think it was working, and that was the problem. I was just under some delusion that this wasn't good enough when, oh, fuck yeah, it was good enough. It was really great, frankly. I was doing just fine. So what the hell? And he was what they call in the good playa. I don't know what the fuck you're talking about. Newton got freaky with it sometimes. I don't know. What the hell? Why do you exist? What is your what are you? Why are you doing this shit talking like you know something about Newton? Ugh, this is pathetic. Jesus, people. I mean, it is sort of an irony of the Bible, you know, is that it really does. There's a whole section where it's basically saying, well, if you want to be a good servant of the Lord, don't get tied down to a wife and kids and all these distractions that'll absorb all your time and just, you know. So that's why priests are supposed to be celibate and all that kind of stuff, is because the idea is if you're going to really be a Christian, you don't fuck around, period. You don't bother doing the traditional family crap. You devote yourself to serving God's purposes in the world, blah blah blah, and that a wife and kids are a huge giant life-sucking distraction. And that's just sort of the irony: is go fruitful and multiply, but if you want to do it right, don't bother being fruitful and multiply. So it's just one of the many contradictions of biblical mush. I mean, Christians are supposed to be a little bit in a burqa. I mean, there's the whole thing about women should have their hair long, so it covers their, their faces and all this. So it's the same kind of bullshit. Oh, Buddhism is anywhere near a point. I'm almost going to block you for that. Well, how does Buddhism get straight to any fucking point? It says you should jump in a fire so you personally get immunity from coming back as a cow. What the fuck is that? That isn't a philosophy. That's just the silliest crap ever invented. How the fuck does it get to any point? Oh, life is suffering, but just keep doing it. Fuck you! That's anything but mush and nonsense. Don't fix anything, just wallow in this shit, because it's all part of the circle of life, fucker. Fuck you. God damn, I can't believe you're stupid enough to make any concessions to Buddhism being anything but the dumbest fucking theory ever. Yeah, well, karma's total shit also. The fact that you're actually going to be reincarnated as some fucking animal is horse shit. What about Buddhism has anything to do with reality? Please point it out to me, how it's got something realistic to say about life on Earth. It has nothing sensible to say. Life sucks, but just keep making more of it. That's a rational statement? I mean, just wallow in the suck. There, life is suffering. Keep on suffering. For no good reason. I'm a Buddhist. Just so stupid. She's... And it doesn't even really believe that life is suffering, right? Because it thinks the only part of that life is suffering is your wants, you know, not your needs, but your wants. And it doesn't think like being horribly killed by some disease is what you're really afraid of. No, that's just something we won't even discuss. So we'll talk about suffering as if, you know, your cat hurt your feelings, you know, by taking a poo on you while you were asleep. Oh, my feelings are hurt, you know. Getting the plague, oh yeah, that's not a problem. But, you know, the cat pooing on you, that's a problem. I mean, the whole thing is just such a pile of shit. Its goal is cessation. Where is that? For you as an individual. By dying by fire. Does that really make sense to you? You escape. And you leave everybody else on the fucking sinking ship. That's a great philosophy in your book? Yeah, fuck you. No, I wasn't defending. Yes, you were. You were saying it's somehow better or straighter or more logical than Christianity. And it's less logical, frankly. It doesn't make any sense at all. It swerves in the direction of some passage and then says something contradiction. Look, the whole point is Buddhism is based on this silly story about some rich Buddha, okay, born to privilege. He finds out his father is a corrupt, conniving shithead, okay, and he realizes that all these poor people are poor for no good reason, and it's quite horrible and it's torturous. And he asks death to explain life to him. And death keeps testing him to make sure he's, you know, he merits having, you know, answers to his questions. And so he tests him with hookers and he tests him with all kinds of ways he can make money and have profit. And Buddha survives all the tests and shows that he has integrity. And then the big punchline is, well, if you want immunity, just jump in a fire. That's the fucking punchline. Fuck you. That's rational to you? That's the punchline? Well, you know, you can get out anytime you want. Just jump in the fire. Yep. Solves everything. For you. Hilarious. Get the plague and die. Problem solved. Oh, is it? Oh, yeah. Oh, God, it's so obvious. Yes, that's a perfect thing to do. I'll go lick a plague spoon, and then everything will be just fine. Oh, God, fuck you. Anyway. Oh, God, you're going to say this again. It's more straight. In what regard is it straight? Fuck you. You keep defending this shit. Heaven and hell makes a hell of a lot more sense than karmatic discontinuation of your evolution to cowdom, the sacred cowdom. Do you really think cows are like doing it right? You know, that's the perfect life? Fuck you. Oh, damn. Oh, people are just so fucking stupid. You shouldn't interact with him, Gary. I know. I don't know why I keep doing it. There's just no point. I keep thinking, well, maybe someday somebody with a brain will show up, but it never happens. So I guess there's no point. So people can't even stay on the subject, so they can't even pass that test. So why should I expect anything from these people? But what choice do I have, right? I really just don't have any options here. This is it. This is the place you have to try to fly from. And there's no wind. No wind beneath my wings. There's nothing. Just shit. Alright, so I will concede failure and move on to the next dismal, insufferable, shitty moments of life. Hate you people. Really do hate you.